Hello guys, welcome again to module number 2 of data management. In this module, we are going to look at data importation, data exportation, variable types, generating and recording variables, labeling variables and values, as well as merging and appending of datasets. And going away, the agenda on importing data. So we'll use import keyword or command to import Excel data, and this just is used to import. It is used to import data from Excel files. And example, we can have something like import Excel colon. So import Excel data.xlx sheet. Import Excel data.xlsx sheet 1 and first row. And we can also import delimited data or CSV following using this command, import delimited data.csv, clear. So this clear command shows that we need to clear any currently loaded data in STATA memory. STATA can only handle one data at a time. And in this Excel, which we are saying first row, it simply tells us that the first row of the Excel file should be treated as column names or variable names. And sheet 1 simply means that by default, we need to import the first sheet of Excel. And we can as well use a keyword which will load a STATA file, and the STATA file ends with a .dta file. For example, you can say use data file.dta and we clear. So clear simply means we want to clear any active data set in STATA memory. And remember, I'm just giving relative path, but I don't know how you've labeled your you've organized your file. So if you have absolute path, then you need to provide, like, let me assume maybe you have a folder labeled as STATA program, and now it contains this data file called datafile.dta. And you can as well export data in Excel, and this will save the data to the Excel format. Export, and this is how we can export using STATA command. You just say export Excel using output .xlsx. So this is the name of the file we would like to name, or we would like to save it as after we export it. And again, we are commanding that the first row should be variable names, which means the first row should be treated as the column names. And you can also use the save keyword or command, and this will save the dataset as now STATA file. Assuming we've loaded the Excel file, like maybe input.xlx, it means that it will be saved, which will contain the same data variables and records, but now the difference will be the extension, which will have now a .dta extension. And let us look at data variables, and don't worry, because each module is arranged in such a way that we do the theoretical part and we transition automatically to the equivalent practical part. And the variable names, we look at variable types, we are going to look at numeric, string, and date. And remember, numeric are just variables with numbers and are used in variables with numbers which are used in calculations such as age, income, and others. Maybe you can say GDP, temperature, etc. And string simply are text-based variables such as the names of respondents, IDs, name of cities, and similar. And we have date, which are stored as numbers but will be displayed in date format using appropriate formatting. And we have now generating and recording variables. So to generate variables, we use generate keyword in STATA, but this one we are going to look further that you can just use gen. We can still use gen instead of the entire word as generate. So this will generate a new variable. So for example, if you say generate age2 to be equal to age squared, it simply means that we are creating a new variable called age2, and this one will be generated based on the existing column called age, and which means that age2 will now be the square of the existing age column. And we have a replace keyword. So replace, it simply changes the values in an existing variable. For example, if we say replace income is equals to income times 1.1, it simply says that we will replace the existing income by increasing their values with a multiplication of 1.1. And we have another keyword called record in data management, that this one will help change values based on specific rules. For example, record gender 1 to 0, 2 to 1, which means, for example, when we initially recorded genders as 1, we are now changing it 1 to be 0 and now 2 to be 1. And we have labeling of variables and values. So label variables, the key STATA command that we use, and this one, the moment we issue this command, STATA will add a descriptive label to our variable. For example, label variable income, so it means the label of the variable will be household income. And for example, we have another one called label define and label values. So label define and label values will assign value labels to a categorical variable. And this is the example. Label define, for example, gender label. In fact, if we say label define gender label, it will be like we're creating a new column called gender label, and we're saying 0 should be male and 1 should be represent female. And now we're saying gender label. Okay, we are now saying label values gender and gender label, assuming now gender are labeled as zeros and 1 initially. Now we are swapping what is here to this now new gender. Now we are swapping the values of gender, which are originally zeros and 1, to now what we've already created, male and female, which means that now the new allocation of zeros and 1 into this gender will be replaced by what is here now. And finally, we are looking at merging and appending datasets. We use merge, and this will combine data set horizontally by matching values in a key variable. And the merge one ID, we use merge one ID using other data.dta, for example. And remember, we are going to do this, sometimes theoretically it might look ugly when we try to explain, but we are going to do this together in practical part, so don't worry. So append will combine data sets vertically, which will stack all the observations together. And example of append, you just need to write append using, for example, additional data.dta. This is the practical part of module number 2. I'm in the do file editor. By the way, to open a do file editor, you need to open your STATA, and you navigate here to a do file editor. This way it tells you new data file editor, and just click here. It will open here, and it's giving some prompt to type something, and you can now start writing your codes here. So, and if you are clear, I hope you can see my screen well. You can see something in some text are in black, some others are in red, others are blue, others are blue, others are green. So you realize that Stata treats these texts differently. So any text you are seeing in green format or green color, those are this. And now I've added here some comments in my data. For example, I'm opening my file, or our module 2 practical part with something like that module data management module number 2. So, and I'm telling the other guys that the file path is located in my D drive as in a program in a folder called, or master folder called STATA program, and the data we're going to use is sample stata cause data.xlx. And what follows is that we will have to do data loading, or you need to import data from Excel. So we first of all, I'm giving step by step of what's going on in this data management module practical equivalent. So I'm telling other guys that, or maybe I'm also reminding myself in the future when I'll be going back to this do file module, that first of all I imported the data from Excel, and remember the first row option uses the first row as the variable name, and so we'll look at it later. And the clear option will remove any existing data in memory. So this is how we load the data. We tell this data that we need to import data from Excel. So we say import Excel, and now what follows is we issue the exact directory where the data is located. And remember, this is an absolute path, but you can create your relative path if you wish, but I use absolute path, which means I'm working from D drive, and in D drive I'm working from a master program, a master folder called STATA program, and inside this master program folder I have a data labeled STATA cause sample stata cause data.xlx, and I'm saying first row clear. So which means I'm telling Stata that please as we import this data, make sure that the first row of this data set to be treated as column names, and you need to clear any data in memory. It's time to run this line number 15. Like I will minimize my screen so you can also see what's happening from this side. So you just need to select the line of code that you would like to issue or to run when importing data in from Excel, and I will give you two options. So this one is using command line to import data from Excel, and this is the button that you'll be using to run or execute your programs in Stata. And remember, I'm using do files, but the same code you can also write them here using this command window. And let me execute this, and realize now after executing we have some data have been some data and label have been populated into this side, and in the variables window, and realize that by default the variable name and label name are equivalent unless we modify later. Like age is also labeled as age, gender is also labeled as gender. Remember, label is just an it adds description to your variable name. I've shown you how to import data using command line. Now I want to show how to import data using the file menu. So to use the file menu, you just need to navigate to file, and you go to import. You say if you want Excel spreadsheet, just click Excel spreadsheet, and this window will pop up, and you need to click on browse, and For example, if I need this data called economic data, I'll just click OK and realize that by default, the variable names are also recognized as rows. So to make sure that they are not recognized as rows, you need to click here, check this box, import first row as variable names. To click OK, and you realize that data in memory have changed. Do you want to continue or lose the unsaved data? So status, as we said previously, that STATA can only handle one data in memory. So it means that it will be replaced. The data that we had already will be replaced. So I just click OK, and realize now we don't have the data set we had previously, and that's how you can dynamically import data through this file menu. So we will stick with our dataset, our previous dataset. So let us execute this and we proceed with our analytics. Use this module number 2. So after now successful importation, we can view the structure for datasets or variables, types, and similar. So to do so, we need to type the word describe. And remember, this describe can also be typed here in command directly. Describe, and just hit enter. So it will give you it gives you this outcome that the data contains 50 observations of 10 variables, and the memory that is used is 3 KBs, which are around 3 MB, and we have some summary of variable name and other stuffs here. And the browse command, of which you can also issue directly to STATA command, the command window, and it will give you now your data as an Excel. So you can view it as an Excel, and you get the dataset contains ID, age, gender, income, education, religion, employment, health status, year, and survey weight. Those are the variable names. And what follows is that we might also be interested to see this data in now editable mode. So editable mode, it means that you can edit data directly. So for example, if I want to change this age to 30, for example, from 29 to 30, I can just type 30 and click enter. You get that I've already changed that. So that's how you can use it in STATA. If maybe you want to edit some variable that you would like to do so. But we also need to understand that STATA is a terrible data entry software. So it's good if you can maybe enter it in Excel and then do direct importation. We want now again to save a copy of the original data in STATA format for later use. Why are we saving this? Because from the objectives, we learned that we want to do what we call data appending and data merging. So we want just to have two copies of dataset that we want to use it in the to show how we can do data appending and data merging in STATA, and to save the original data, which means the Excel data that we've just loaded, you need to save it using this code. Just say save, and we are telling STATA to save the current data in memory into this directory, and it will be labeled as part1.dta. This is the master folder where I'm working from. So currently I don't have anything called part1.dta, but as the moment I hit save, so at the moment I run this line, let me say save, and then navigating to where the STATA program is, the master folder, the data part1 is here now. You can check the timestamp is 10 AM. and the data is .dta, which means it's a STATA file. We want, again, the next process is to create a duplicate dataset for learning how to now to append. So we want to use now the dataset that has been saved, which is this part 1, by saying use. Now assuming that it is saved but now it still is not in use, that's why we are using the use command. And we can now browse and check. So we realize that after browse, now if we after issuing the command browse, we realize that we still have the same data that we had as Excel data, but now this one is a STATA data with the STATA.dta extension. So what follows that we want to modify some values to simulate the second wave of version of the data, like adding 5 years to each year value to simulate time passage. So this is what you can do, like we run that replace year. So remember, year is one of the column name with 5. Okay, with the year plus 5, which means if the year, first of all, let me browse before we add something. So this is the year. So we want to modify this data so that it looks like it's a different data set. So we want to add this to be 5 years to this original one. So it will be like, if it is 2020, it will be 2025. If it is 2021, it will be 2026, and similar. So let me execute this, line number 36. And now let us again try to browse the data, check the year column. Now you realize the year column has been modified from what we saw. The original was 2020, now it's 2025. 2021 was original, and now the new one is 2026. And now we want to again also to modify the gender. For example, the gender, we can use something like you can say gender mod, which means gender modified. So this one will translate to, for example, if the gender is male, then it will be gender mod. It will be gender mod instead. So let me do this. So remember, first of all, let us view the gender column before we replace. The gender column here, you have male and female, similar. And after we do modification, it will be like gender underscore mod. If it is male, it will be male underscore mod. If it is female, it will be female underscore mod. So let me run this line, and now we check now what has happened to gender column. And now I hope you see the modification we've done throughout the gender column. And now we can save this data after modification as part2.dta. And now again we can browse and still know that this data is still active. And what follows that now we are moving to our section, or the key objective, called merge and appending. And starting with appending, appending simply appending dataset or stacking rows together. So we want to start by using our dataset number 1, which was part1.dta, and we'll assume that this is the now master file, and we run. And now to append data, we just need to issue a command called append using so we need to use append using the dataset number 2, which is, I can say, the child data. So we want to stack this part 2 to this part 1. So if we execute this line and check our command line, we realize that append using this command was run successfully. And now we can describe our data after appending. So you realize that our data after appending is now having 100 observations, but initially there were 50 observations, which means data 1 and data 2, which is part 1.dta and part 2.dta, have been successfully bundled on top of one another. And the variables did not get affected. There are still 10 variables, column names. Now we can issue a command called list, which will show us all the observations and variables at once. So this we have all these variables have been listed here in the result window. So now this is the result of the appended data. So we realize that the dataset 2 starts from 51 and dataset 1 ends from 50. So you can see how this is how this column looks like from this male underscore mode, but here we don't have something like this one. We have also female underscore mode, which shows that this dataset was bundled at the bottom of the original data. The dataset called part2.dta was from what you can see from the final data. And we can now proceed with merge. And merge, we use, first of all, you need to use the part 1 to be a master data. And so this is the key command we use to merge. You just need to issue the command called merge one on one ID using our this second data called part2.dta. So in a nutshell, we are simply telling this data to match rows from part 1 and part 2 where ID is the same, and now we need to combine their columns or variables. And we need now, after running this, we can now again run the describe command. So first of all, I issued already. I had issued the command for merge, and maybe if I'm still doubting myself, then I can still issue the same command for merge. Yes, you realize that not merge and merge, you have 50 and 0 respectively. So we can now again describe the data after merging. We realize that there is something unique here, that observation have now reduced from 100 to 50, and the variables have now increased from 10 to 11. And what follows that we can try to browse our data. So we realize that this is the additional column that was included, or variable underscore merge. So let us see why so. We can as well, first we will see later, but let us first of all see list the variables now after merging. So after merging, this is what we found. And now let us try to go to the theory. So a STATA matches rows with the same ID and combines their variables side by side. So however, if both datasets contain variables with the same name, like now in this case we are comparing gender and year, which we modified, so STATA does not overwrite or append values directly, but instead it will preserve gender from the master dataset. And in this case our master dataset was part1.dta, and gender underscore using from the using dataset part2.dta, and if the variables or if the values differ or if gender was modified, then it will be given as gender underscore using. And now to inspect the result of the merge, in fact we used the browse command to open the data viewer, and we reviewed how variables were merged or suffixed. Guys, I hope that makes sense, and maybe if you need further studies, there are a lot of materials and others I'm going to append it here. So thank you for being here, and we're moving to our next agenda of how to export data in Excel. So to export data to Excel, we use the export keyword or export command. We just need to issue export, and then you say which version you want to export your data as. If you're saying export Excel, now you need to also specify where is the data coming from. So the data is coming from this location, and we want to export it from here. So it means that we want to export data to this location, this master folder called STATA program, and the data that should be exported will be renamed as exported data1.xlx, and first row as variable name, and we replace is equal to true, which means we want to replace any instance of this data, which means if you have this data from this master folder, it will be replaced. So I'm in the master folder. This is the master folder, and I want to check if we have something like export data. Data 1, I realize we don't have, yes, we have this one. So let me just delete. Yes, I have deleted it successfully. Now let us export it, and let us now check and realize that voila, we have this data. Checking on the timestamp is 10:23 a.m. It has been exported, and so now after exporting that data, we can as well save the same data as a dta.dta, which means the data version of the same. So from our master data, we don't have okay, we already I had already done this on date 5 of 20 it was 21st of May, but I can delete this. And now let me rerun this one by saying save exported data1.dta and execute. And from the master folder, you realize that we have this one as 10:24 a.m. The data has been exported successfully. And what follows is we are moving to our study agenda, which is working with the variables, with the variable types, and we're looking how we can convert numeric variables to a string equivalent. And this numeric variable we're referring to is just age column. So it's the age column. So this is the age column. We want to convert it to a string equivalent. So instead I will say when you issue the keyword like gen, it simply means generate. So we're telling STATA to generate a new column called age string. So currently we don't have a column named age string, like we don't have something like that. But by running this command, we will have a new column generated, but we are saying that this age string will be equivalent to the string values of the age column. So if I run this, now we realize that the command has been generated successfully, has been run successfully. And if I scroll down, we realize now we have a new column called age string. As well, we can convert back the age to an integer, like age num should be the integer of age. So we run and we find that. Let us now browse and check our outcome. So we have these two columns that have been generated. You have the one with the age strings in the color red, the age num is in color black. So if you see color red, just know that is a string data. That's a string data. But if you see color blue, that's not that is an factored data. Anything in red, I don't know if it's red or orange, but you just know that is a string, a representation in STATA. And what follows is that we can create now a new date variable from the year, assuming that all dates are now starting from January 1st. This is the equivalent command we can use, that we just need to say Jane. For example, we want to create a new column called survey date, and we pass on the command mdy bracket 1, which means January 1st of January, and then the year. And remember, the year will be a replica of what is in our data set. Let me browse, and this is the year. For example, it will be now, if it's the year 2020, it will be the 1st January 2020. If it is 2021, it will be 1st January 2021. If it's 2022, it will be 1st January 2022. And let me just execute this command, and it has run successfully. And now what follows is to format this data so that it can be a date. So we write this syntax: format survey date percentage dt, which means as date form, as date time or date data. So remember, survey date is the column we created, and you just need to run. After running that, we can browse to check the changes. Now you realize that you have survey date at the far end. Now you realize this is the survey date. You have 01 Jan 2020, 01 Jan 2021. The way I just gave you the hint, 01 Jan 2022. And now we have how to generating new variable. For example, we want to generate a new variable called income underscore k that will show the income in thousands. So to do that, first of all, you need to use the command gen to generate a new column. So we're telling STATA to generate a new column called income underscore k, and to be created based on the income variable that is existing divided by 1000. So if I run this, a new column will be generated, and let us browse first before we label it. Hello. Nzuri.
Salama. Oh, niko na mazuri hapa, nguo za lady. Ningependa kama wako wakaribia waone walichomoka.
Asante, hawako hata.
Wametoka?
Ah, asante. So let us check. So let us check the column called income underscore k. This is the column that was generated based on the real income column. This is the income column, and for example, for income column 30,000, we have the equivalent as 30 because we have divided it by 1,000. And now what follows is that now we want to, in fact, let me show you something. I wanted to show you something that if you are keen with this, the few section of these columns, we realize that these columns lack variable names. They are not labeled. But for example, health status is labeled as health status. Are you seeing this? Health region is labeled as region by default. Year is year, and survey weight as that. But this one do not have labels, so we can add descriptive names dynamically, and this is how we do it. So we want to label the income column as income in thousands. So running this and now checking our variable income, we realize now we have this income in thousands. And we can also group ages into categories. For example, group 1 can be 1 for young, 2 for middle-aged, and 3 for older. And this is how we do it in STATA. I just need to say record age 0/30. This one does not mean a fraction, but it means that it is 0 all the way to 30 will be regarded as 1, and this one represents young population. And anyone who is aged between 31 to 50 will be regarded as 2, and which will represent middle population. Anyone in 50 to 100 will be regarded as group 3 with older equivalent. So executing this, and we will have our the column recordings, and we can label that as the variable age group, which means that age group will be 1 for young, 2 for middle, and 3 for older. And to do this, we can still browse to check it. And remember, the new columns are created at the far end of your data. And remember, you have age groups that has been generated, that if someone is 30, okay, it's below 30 should be regarded as 30, and below should be regarded as young. So let us go to this. In fact, is the age. Like someone is 25 is regarded as young, someone's 34 is regarded as middle. Okay, someone's yes, 34 is regarded as middle. Someone in 53 is regarded as older person, and similar. And now there is a way you can also modify your data. Like for example, if income is 0, we can assume that the person is unemployed, and we can tell STATA that we need to replace employment is equal to unemployed if the respondent provided the data as 0. If the data provided their income compensation as 0, so we'll assume that guy is unemployed. And this is what we will do. We just need to execute this, but in real sense we don't have that. That's why I say real changes was updated. But now let us try to do so. Let us just try to create our own generic column. Let me just do edit. Let us edit and modify. So let us go to where someone said level of income and say they're employed. So for example, employed, let me say go to here, and maybe someone said here male, and said the guy is employed but 0 income. Column number 10. Yes, I will change it. And if I go back and I say here now, I rerun this line that replay employment equal to unemployed if income is equal to 0. Let me execute this. Let me minimize and execute. And you realize here we are being told that one is real change made, which means that the one column that we modified is the change that the STATA is referring to. Now let me browse that. You realize here this is the column row number 10, where the person was called employed initially, now is unemployed. I hope now you see how data management STATA is crucial. And what follows is labeling of variables and values. So we can add a discrete label to, for example, health status variable. We issue the command label variable health status as self-reported health status. So variable, remember, this is the column name we already have, but now we want to modify the default variable name, the value label as from health status to something like reported health status, self-reported health status. So first, before we do that, let us go back here and check where the health status is. This is the health status, and you realize that the default label name is still also health status, but now we want to change this to something fancy. And this for something fancy is what you want to say, call it self-reported status. So by running this line, we will have such kind of a representation. So now we can navigate to health status, and we realize now we have changed it successfully, self-reported health status, from health status to self-reported health status. And again, we can now change gender labels, like 1 for male and 2 for female. Again, if we execute this, we'll have to get something like that. And now we want to create a new column called gender code of the label we've just created here. And this gender code will be a new column, but will have empty records. And these empty records will be populated later. So this will create a new variable called gender code, and it initialize it with values to missing for every observation. That's why it's equivalent to missing or empty records. And what is we are doing next to replace the gender code is equal to 1 if gender is equal to 1. If the gender is equal to male. So before we execute line 138, let me go back to our data set. In fact, I can browse the data set, and let us go to the new column we created here. I hope I'm here to create the column. I did not create this, so let me first of all run this. We've executed that. You can go back now to our data set. So this is the column we created. It is currently missing, having missing data. So, and instead I know it's complaining that we have 50 missing values, which means all the records are missing for that column. Now, what follows now that we want to replace the gender code is equal to 1 if gender will be male. So this, let me go back here. So it means that if we get the gender, this is where where's gender? Okay, the gender. If the gender is male, then this column will be labeled as 1. Will be labeled as 1. Else will be labeled as 2. So let me run this now. Okay, it's this one. I should run this, and again I should also run this for female. So let us check now our data. Now you realize this gender code has been populated. We don't have any missing values anymore. It has been populated. Yes. I hope this is interesting, guys. And now finally you can create value labels for that gender code, because by default it will be empty, and we will name that as gender 1 for male and gender and 2 will be for female. And now we can browse to check what has changed. So now you change the 1 from 1 to male and 2 to 0 to male and 2 to female. Exact thing we've just done. We just the reverse of what we did previously. I hope this guys makes sense to you, and we'll use this into practice. And this is the end of module number 2. So see you in module number 3 of STATA. Thank you.